Alrighty, students, before we get started with circles, I have some vocabulary that I want to go over with you, and I would like you to jot this down in your notes. So I'm going to give you a second to pause the video, jot down these words in the table. Go ahead and draw a table out, and some circles. Alright, pause the video. Make sure you pause the video to get this all written down because I'm about to get started. So, we're going to start with the word center, and the center of a circle is a point, is the point really, that is the same distance from every point on the circle. It doesn't have any units of measure, but it is labeled with a capital letter. So for our next vocab word, diameter, this should be another one we're familiar with. Let's go blue. It's going to be a line segment that passes through the center and the two endpoints are on the circle. So it could also look like this. These are all diameters. And then units of measure, we can measure them in centimeters, meters, inches, feet, etc. Now we have the next one is another one that should be familiar for us. It is the word radius. So we're going to have our center again. The radius is a line segment whose endpoints are so one of them, the center of the circle, and two, the second one is a point on the circle. So what does that look like? It looks like a little line going out like that. This is a radius. This is also a radius. This is a radius. This is a radius, and we usually write a little r. And this is again centimeters, feet, inches, meters, etc. These next two boxes are new. These are new vocabulary words that are really important for us to know. So again, we're going to start with the center of our circle. So sector is a part of the circle enclosed by two radii. So what does that look like? That could look like here, here, and the space in between the two radii, that is a sector. Sector area is really just the area enclosed. The area enclosed by the two radii. And it's measured in units squared, like area always is. One more word for you today, and that is central angle. So we have center point C. A central angle looks like this. So we're going to take two radii. Yeah, I'll go here. I feel like I'm always going here. And the angle that's formed here, remember we use theta for angles. This is what we call a central angle. It's an angle whose vertex is the center of the circle. So it's this angle that we're talking about, and it's measured in degrees. Now make sure you have this vocabulary down, because we're about to use this for figuring out something. How do we figure out sector area? So pause your video if you need to. Finish copying this down, because I'm going to move over to another document. Okay, so before we start with sector area, let's just talk about probability. So we've got two spinners. Assume each section of the spinner is equal. Then what would the probability of landing on the shaded sector be? Well, for this first one here, there's 1 part shaded and 2 parts total, so 1/2. The area of a circle is pi times your radius squared. We're given our radius is 4, so 4 squared is 16, so area is equal to 16 pi units squared. The shaded sector area, well, since these are equal pieces, I think it'd be half. So I'm going to divide by 2, and I'm going to get 8 pi units squared. Then I'm going to do the sector area. That was the 8 pi over 16 pi, our total area. And I'm going to get, well, 8 divided by 16, that's 1 over 2, and the pi's cancel out. The pi divided by pi is 1. Total degrees in a circle, there are 360 degrees. The degrees in the shaded sector, so we're saying, what is this? How many degrees are in a straight line? 180 degrees in a measure of angle ABC divided by the total. Again, as a ratio, that is 1/2. I'm going to pause the video, and I'm going to ask that you try to do these two pieces on your own. Okay, hopefully by now you have tried these two. You pause the video. So I'm going to fill in the area here is still 16 pi. Well, now we have 1/4, so divide that by 4 and we get 4 pi. We should get 1/4. The total degrees is still 360. Here now we have 90 degrees. 90 over 360 equals 1/4. Here we have 1/8 of the slice. Area, total area is still 16 pi. The area of just the shaded sector is 2 pi. When we divide these two, we get 1/8. This is still 360. This is now 45 degrees, and this is now 1/8. So looking at this filled in table, our question is, what do you notice? What is the same? So I'm going to give you a second to pause your video and circle the rows that are the same here. So you might have said that the area always stays the same. That's true. What else is the same? Well, this row, these values are different, but they are the same as this row, and it's the same as this row. So a generalization we might make is that the probability of shaded area is equal to our sector area over total area, which is equal to the degrees in the measure of angle ABC divided by the total degrees. And this right here is a big idea that's going to help us figure out how to find sector area when things aren't as clean cut. So go ahead and write this right here in yellow down. This is our big idea. That sector area divided by total area is equal to the degrees of the central angle divided by the total degrees. And now let's use it. So if you need to pause the video to catch up. Write it down. Okay. So here we have a circle. Find the sector area given the different central angles. So here, the measure of angle ABC is going to be 30 degrees. So we're going to set up that ratio of degrees of our central angle. New vocab word. Divided by the total degrees. Area of the entire circle, our radius is 6. So that's, reminder, pi times radius squared. So 6 squared is 36 pi. And then we want to use these two pieces here to find sector area by setting up that yellow equation. So sector area, we don't know what it is, so we're going to give it an x divided by total area, 36 pi, equals our ratio of our angles. And now here, we're going to want to undo, multiply by what we're dividing by to get our denominator out. Whoa. Please stop. Divided by 30, oops, nope, we don't need to, just, there we go. So these cancel out, and we have x is equal to, and out here we're just going to use our calculators. That's fine. 30 times 36 divided by 360, and we get 3 pi, which is approximately equal to 9.4247 ... So that is our sector area. The area of that shaded sector is 3 pi. What if that was not 30? What if it was 20 degrees here? We're going to basically do the same thing. So I encourage you to pause the video and try this one out on your own, and then watch mine to confirm. Central angle divided by total degrees. Total area is still 36 pi. Set up our ratio. Undo, multiply by the denominator. X equals, use your calculator, 2 pi, which is approximately equal to 6.283 ... And last one. Here, now this is our central angle, so 22.6 degrees over 360. Total area is still 36 pi. Set up our ratio. And again, we undo. So multiply by 36 pi. And these two cancel out. 22.6 times 36 divided by 360. X is equal to 2.26 pi. Or if you have the approximate 7.0999, lots of nines. If you would like to see a couple more practice before getting to Desmos, here you go. You're going to have to draw your own circle. Radius of 3 inches. Central angle of 72 degrees, so we're going to draw in 72.3 degrees. And if this is our shaded sector, we want to know the probability that a dart would land in it. So the probability of the dart on shaded, we know that that's going to be equal to the sector area. And in order to find sector area, we need to calculate the total area, which is equal to that ratio is equal to our central angle divided by total degrees. So our total area is going to be 3 squared, which is 9 times pi. And sector area, we'll call that x. Let's do our undoing. pi times 72.3 divided by 360. So that's our sector area. So the probability that the dart is going to land on shaded is our sector area divided by our total area. Nice. Try this last one on your own, and then I'll put up my results. And we know, let's just call this X. Undo. There we go. All right, I hope you have a good rest of your day, and check in if you have any questions.